Pressure is the amount of force applied to a given area, measured in Pascal. The SI unit of pressure is Pascal. A Pascal equals force of 1 Newton over an area of 1 meter squared. So the formula is P equals F over A. F is force, A is area. So the more force you can apply to an area, the greater the pressure. It has a reverse relation with area. So the smaller the area, the greater the pressure. That's why, for example, with a little push, a pin goes into the skin of our hand, which means when the area is little, a needle can easily go into our skin, but a nail, it is difficult for a nail to go into our skin. So the smaller the area, the greater the pressure. Okay, this is an example. You have a force of 10 Newton on an area of 2 meters squared. What would the pressure be? So area is 2 meters squared. Force is 10 Newton. What is the pressure? Pressure is force over area. So pressure is 10 over 2, which is 5 Pascal. Because both force and area are in SI units, no unit change is needed. So I need to emphasize that Pascal is the same as Newton per meter squared. If you want to think of Newton as joule per meter, and we can find another unit for Pascal. Pascal is joule per cubic meter. This is the unit of work or energy. This is the unit of volume. So work or energy divided by volume will be pressure. Okay, these are all units of SI units of Pascal. Okay. A woman's high heels sink into the soft ground, but the larger shoes of a much bigger man do not. So again, because when the area is small, a great pressure will be exerted, which is the case here. When the area is small, a small force causes great pressure. So this high heels go into the grass, which is a soft ground here. But in this case, the weight of the man is greater, but the surface area is greater. That's why it doesn't go into the soft ground. Okay, let's do an example here. A rectangular cube of mass 5 kilogram has the following dimensions: 2 times 3 times 5 centimeter. What is the ratio of the highest pressure to lowest pressure when they put it from different sides on the ground? Okay, so we have a box, we have a rectangular box like this, 2 times 3 times 5. It's a box like this. So this is 2, this is 3, and this is 5. We have 6 sides. The largest side is this one, the top one. So because the dimension is 3 times 5. And the smallest side is this side. Let me show it by red color. Here it is. This is the smallest side. But no matter on which side we put this rectangular box on the ground, the mass or weight is the same. So what is the weight of this box? So what is the weight of this box? The weight, which is kind of force is mg. M is 5, G is said to be taken 10. So the weight of the box is 50 Newton. So the weight of this box is 50 Newton, no matter on which side we put it. If I want to calculate the maximum pressure, I need to apply the weight over area. But which area? The minimum area. When area is minimum, the pressure will be maximum. So this will be 50 over 2 times 3. You may wonder why I'm replacing the area in centimeter. So centimeter times centimeter will be centimeter squared. But I don't want to calculate the Pmax. Of course, I can calculate the Pmax in Newton per centimeter squared. It doesn't matter. The question has asked for the ratio of the highest to lowest. So I just leave it as it is. And I will go to find the P min, which is the minimum pressure. So the same weight, now this time over the maximum area. What is the weight? 50. What is the maximum area? 3 times 5. This is the maximum area. So now we want the ratio of the maximum pressure over the minimum pressure. Of course, we can have 50 over 2 times 3 over 50 over 3 times 5. A far by far, near by near will get 5 over 2 or 2.5, which is the ratio of the longest side of this cube to the shortest side of this cube. Okay, let's continue. Pressure of liquids. Pressure of liquids is given by this formula. P is equal to rho GH. Rho is the density of the liquid. So it depends on density of liquid. So it depends what type of liquid we're talking about. If we go into the depth of a liquid, the pressure will be greater. So whether the liquid is water or alcohol or, for example, bromine, or it is mercury, it differs because mercury is very, very dense, but water is some medium liquid. Okay, it depends on the density of the liquid. So the more dense the liquid, the pressure will be higher. If the same depth, if we go into the liquid, same depth. Okay, G is gravitational acceleration, which is 10 meter per square second, or 9.8. Usually we take it 10 for approximation, for simplicity. H is the depth of water. So if this is the surface of water, and this is air, and this is a liquid, for example, or we can take it as air, H will be calculated from here. So at this point, H is 0. So the deeper we go, H will be greater, so pressure of liquid will be greater. This is only pressure of liquid. Okay, so these are units of pressure. Bar, we already know Pascal, which is SI units, which is Pascal is Newton per square meter. We write other units based on what we have learned. Bar is 10 to the 5 Pascal, or 100,000 Pascal. Atmosphere is another unit of pressure. It is 101 1,325 Pascal, or roughly we can say 1 atmosphere is equal to 1 bar, because this is 101,000 Pascal, this is 100,000 Pascal. Okay, they're roughly the same. Centimeter of mercury, 76 centimeter of mercury is equal to 1 atmosphere. And millimeter of mercury, 760 millimeter of mercury is equal to 1 atmosphere. Torr is another unit of pressure which is equal to millimeter of mercury. PSI is a British unit for measuring the pressure, and this is roughly equal to 1 atmosphere. 1 atmosphere is roughly 14.69 psi, which is pound per square inch. Okay, just know that psi is a unit of pressure. Let's do one example. Find the pressure of water at depth of 10 meter. Density of water is 1,000 kilogram per meter cubed, and G is said to be taken 10. Okay, so what was the formula for pressure of liquid? P equals rho GH. What is the density of liquid? Density of liquid is water. Density of water is 1,000. Pay attention that if we replace the units in SI units, we'll get SI units here. If we don't replace SI units, the units for pressure will not be Pascal. Okay, so I replace all the units in SI units. So density of water is 1,000 kilogram per cubic meter, which are SI units. Okay, so 1,000 times G is 10, and what is H? H is 10, because it says go deep into the water 10 meter. So it will be 10 to the 5 Pascal, or roughly it is 1 atmosphere. Let me write 1 bar. This is 1 bar, or roughly 1 atmosphere. So 10 meter of water has a pressure equal to 1 atmosphere, roughly. It is good to know that we can every kind of liquid we have, for example bromine or mercury, and every depth of that liquid can be a unit of pressure. For example, meter of water is a unit of pressure. For example, 10 meter of water is equal to 1 atmosphere. Or we have some other units of pressure, like millimeter of bromine, or centimeter of bromine, or centimeter of mercury. So a unit of length or depth and a type of liquid. This makes a unit for the pressure. Okay. How to calculate pressure of gases? What can we say about pressure of gases? Pressure of air on surface of Earth is due to depth of air molecules around the Earth. It is 1 atmosphere. So pressure of air around the Earth is roughly 1 atmosphere. 1 atmosphere, I say roughly because at sea levels it is 1 atmosphere. If we go up in the mountains, the pressure drops. The pressure is lower. The higher we go, air molecules are less dense, so the pressure drops. So if we go high in the mountain, the pressure decreases. The pressure will be less than 1 atmosphere. This is Torricelli's experiment. Torricelli filled the tube with mercury. Torricelli filled the tube with mercury and inverted it into an open container of mercury. Air pressure acting on the mercury in the dish can support a column of mercury 76 centimeters in height. So here is vacuum, because initially it was totally filled with mercury. Now that mercury has dropped, this is vacuum here. Here is vacuum. So there is air pressure here. This air pressure can keep this 76 centimeters of mercury high in this tube. So Torricelli found that air pressure is equal to 76 centimeters of mercury. 76 centimeters of mercury is equal to 1.01 times 10 to the 5 Pascal, or as I said, atmosphere. A standard atmospheric pressure is 32 feet of water, or 14.7 pounds per square inch. This is the same as PSI. Okay. Total pressure. At depth of water, pressure of water can be added to the pressure due to air. So we can say total pressure is equal to P equal to P0 plus rho GH. P0 is the pressure of air, and rho GH is pressure due to the weight of water. That is pressure due to water, liquid. So they can be added to find the total pressure. Let's do one example. Find the total pressure at depth of 10 meters of water. So let me write P is equal to P0 plus rho GH. We found in the previous question that, let me take P0 as 1 atmosphere. We found in the previous question that 10 meters of water is equal to 1 atmosphere. So 1 atmosphere plus 1 atmosphere will be 2 atmosphere. The total pressure at this depth of water is 2 atmosphere. Or I can write, this is 101,325 Pascal, and then this will be 100,000 Pascal. The total will be roughly 200,000 Pascal. Okay, the units, we can state the total pressure in different units, but whatever unit we say, the result doesn't vary.